Hello! Today we explore clustering tasks, grouping similar things together. Imagine you have a large collection of items like different types of fruit mixed together in a basket. How would you start to make sense of them? You'd probably begin by grouping similar fruits together, putting all the apples in one pile and all the bananas in another. This intuitive act of sorting things into groups based on their shared characteristics is exactly what we call clustering in the world of data. It helps us find natural divisions within a dataset. At the heart of clustering is the idea of similarity. What makes two items similar? Visually, if we plot data points on a graph, points that are close together often share common traits. For example, customers with similar purchasing habits might appear close on a graph. We look for these visual bonds where items naturally belong together because their characteristics align, suggesting a shared underlying pattern. Once we understand similarity, the next step is to identify natural groups. Imagine a scatter plot where some points are tightly packed together, forming distinct islands. Each of these islands represents a cluster. These groups don't have predefined labels. Instead, they emerge naturally from the data structure. Our goal is to uncover these inherent groupings, allowing us to categorize data points that share strong resemblances without knowing the categories beforehand. So, why is finding these natural groups useful? Clustering helps us understand complex datasets by simplifying them. In marketing, it identifies customer segments, allowing companies to tailor strategies. In biology, it groups similar genes or proteins. For anomaly detection, it helps spot unusual data points that don't fit into any group. In image processing, it can separate different objects within a picture. It's a powerful tool for discovery and organization. Let's consider customer segmentation. Imagine we have data on customer spending habits and their engagement level. We can plot each customer as a point on a graph. By applying clustering, we might discover distinct groups: high spending, highly engaged customers, low spending, low engagement customers, and perhaps a group of high spending but low engagement customers. This insight allows businesses to create targeted campaigns, improving customer satisfaction and retention. While we often visualize clustering in two dimensions, real-world data can have many more characteristics. For example, a customer might be described by their age, income, and purchase history. Even though we can't easily plot these higher dimensional similarities, the core idea remains: items are grouped based on how similar they are across all their measured attributes. This requires computational methods to detect these resemblances. Clustering is a fundamental technique within unsupervised learning, a branch of machine learning. In supervised learning, models learn from data that already has labels. Unsupervised learning deals with unlabeled data, where the algorithm explores the data's inherent structure to find patterns or groupings on its own. Clustering is a prime example of this exploratory, label-free approach. To recap, clustering is about grouping similar data points into natural categories. Similarity means items share common characteristics, often visualized as proximity on a graph. These groups emerge naturally from the data itself, without needing predefined labels. We saw how clustering is used in diverse applications, from customer segmentation to identifying anomalies. It's a powerful unsupervised learning tool for uncovering hidden structures. Thank you for watching. Please like and subscribe for more educational videos.